This video is just going to go over a little graphic helper for the mole concept. And right now in our class, we're not doing the volume part of this, so don't pay attention to the volume part for this. Okay, so we're going to be looking more at the atoms to molecules calculations and our atom mass and things like that calculation. So as we start, we're going to see that this visual here, if I'm given atoms and I want to go to mole, that's a one-stepper. So that means I'm going to go atoms directly to mole by using the 6.02 times 10 to the 23rd number. And that's going to be by division. Everything on this side of this chart is division. Everything on this side of the chart is multiplication. So if I want to go atoms to moles, that's a one-stepper. And it says we're going to divide by 6.02 times 10 to the 23rd. What about if I'm going from mass to moles? Well, from mass to moles, again, that's a one-stepper because the word mole is in the question. It says take the mass divided by the molar mass. That's what goes there. And of course, on the right side, if we're converting from moles to atoms, we're going to times by the 6.02. That's a one-stepper. And if I'm going from moles to mass, I'm going to multiply by the molar mass. That's a one-stepper also. But there is possibility to have two-steppers. Then the word mole is not written in the question. Thus, if I go from atoms directly to mass, I got to go atoms to moles first and then moles to mass. So I'm going to divide by 6.02 and then multiply by molar mass. And if I'm going from mass to atoms, I'll divide by molar mass first to get the moles, and then times by 6.02 to get to atoms. Let's try this with two questions here. We'll fast forward here. How many moles are there in 13.4 grams of potassium? Well, the word mole is in the question, so I know this is a one-stepper. So I put my 13.4 grams of potassium here, and I'll quickly make just my one step and get that equals. And then on the right side, what do I want? I want moles. Okay. So now let's go back to our question here. Okay, so I've been given mass and I want to get the moles. So it says we're going to be dividing by molar mass because it's just a one-step question. So how does that look for our bridge? Well, I'll put molar mass on the bottom. That's what division means. So 39.0983 grams of potassium. And what goes on top? Just 1 mole. Okay, so we're going to take 13.4 divided by the 39.0983. And that gives us 0.343 moles of potassium. So that's how we use that little bridge chart thing that I found. Okay. So the next question, how many grams are in 2.43 E23 atoms of lead? Well, the word mole is not in this question, so now I know that this is a two-stepper. So I'll give myself a little space. So I'm going to go times and a blank, and a times and a blank. Now before you do anything, we know the word 1 mole will be on top here, and 1 mole will be on the bottom here. This is always true of our two-steppers, because we must get the moles first and then get out of moles. So what do we know on this side? We have 2.4 E23, and this of course is atoms of lead. Now I can put PB next to both of these. And I want grams, so this will go to grams of PB. Okay, so now our job is just to fill in these two pieces here. If we go back to our visual helper here, we want to get from atoms to mass. It says divide by 6.02 to get the mole first. And then what do we do next? We times by molar mass to get the mass. So again, our first steps from here to there are always division. Our steps from here to this side are always multiplication. So let's go back. Now I know 6.02 times 10 to the 23rd is here, and that's atoms of lead. And on top here is 207.2 grams of lead. And again, that comes from the periodic table. And the answer is 82.6 grams of lead. And that's how we do it. So that's how that visual works with it. The next part of this warm-up today is determining an empirical formula and then a molar mass. And again, I've chosen to do this by chart form. And I've recorded the instructions also for you on this presentation. They are listed for empirical formulas, there's our process. And for molecular formulas, there's our process. So that's written in words. So what do we really do? We're going to take this carbon, this hydrogen, and oxygen, and we're going to convert those to moles. Now 40.0% is the same thing as 40.0 grams. And then 6.7 is the same as 6.7 grams. And 53.3% is the same as 53.3 grams. So what will I do? I'm going to divide each of those by their masses on the periodic table. This will be 12.01 grams. This will be 1.01. And this will be 16.0. I'm not using as many sig figs today. Now what answers do we get out of that? You get the 3.33, 6.65, and 3.33. Now remember, all of these are moles. And again, I'm choosing a chart form instead of actually writing out the mole. I just think it keeps it more organized for ourselves. So then our next step, after we divide each by their atomic masses, we'll divide the least number of moles into all the larger. In this case, it's 3.33. And that may give us some whole numbers. This one gives us 1. This one gives us 2. And this gives us 1. So then I know the empirical formula for this is CH2O. But there's an actual molecular formula that needs to be determined because this is a covalent molecule, and the mass spectrometer tells us that that's 180 grams per mole. So now how do we figure that out? Well, down here I'll do that. So I'm going to take the mass of the empirical formula. So I've got 1 carbon, I've got 2 hydrogens, and I've got 1 oxygen. So this is 1 times 12.01, 2 times 1.01, and 1 times 16.0. I'm going to add all of these up, and that gives me a grand total of 30.2. Actually 30.02 grams. So this is the mass of our empirical formula. So what I'll do, I'll take the 180 grams that we have for the actual molecule and divide that by 30.02 grams, and we'll get a whole number out of that, which is 6. So what that means is I need to take this thing right here and I need to multiply all of this by 6 to get the actual molecule formula. In this case, that would be C6H12O6. C6H12O6 is the actual molecular formula, and you should know that as glucose. So that's how you do empirical and molecular formulas.